Chris shoots a half-court shot 11.9 meters away from the basketball hoop. Find the initial velocity in which he has to shoot the ball to make a basket if he releases the ball at a height of 2.05 meters at an angle of 45 degrees.
When solving this problem, we're going to neglect air resistance and say that the height of the basket is 3.05 meters, and then we will list our 5 variables in the x and y direction.
Displacement in the x is 11.9 meters. Acceleration in the x is 0 meters per second squared. Final velocity is 0 meters per second squared, and our two unknowns in the x are time and initial velocity. To find the displacement in the y, we took the height of the basket minus the height of which he shot the ball at. The displacement in the y is 0.65 meters. The acceleration is negative 9.8 meters per second squared, and the final velocity is 0 meters per second. Our two unknowns are time and initial velocity.
When we first start solving, we are going to solve for time, and we're going to have to find our initial velocity in the x and y direction. And we get initial velocity in the x direction to be initial velocity times cosine of 45, and in the y direction it's initial velocity times the sine of 45. And we're going to take our initial velocity in the x and plug that into our motion equation that doesn't involve final velocity since it's not important in this problem, and we get it to be x minus x naught equals VO xt plus half of at squared, and the second half of the equation will be 0. And then when we solve for time, we get time to equal 11.9 meters divided by 0.707 times velocity initial. And we're going to take that value for time and plug it in the same equation except in the y direction. Then we get 0.65 meters equals 0.707 times velocity initial times 11.9 meters divided by 0.707 times velocity initial minus half of 9.8 meters per second squared times 11.9 over 0.707 times velocity initial squared. And then once we do all the algebra, we have to solve for velocity initial, and we get that to be the square root of 4.9 meters per second squared times 283.2 meters, all divided by 11.25 meters, and we get our initial velocity equal 11.1 meters per second.